The vibration starts in the soles of your boots. It travels up through your shins, settles in the base of your spine, and eventually, it becomes a physical weight inside your skull. It is a constant, rhythmic assault. 4 massive Allison turboprop engines, mounted to the wings of a P-3 Orion, are churning through the thin polar air, screaming at a pitch that noise-cancelling headsets can dampen, but never truly erase. Inside the fuselage, the air smells of recycled oxygen, stale coffee, and warm electronics. It is a sensory bubble, a chaotic, mechanical island of noise. But outside the cockpit glass, there is only silence. And there is only white. It is August 2013. We are flying 1,500 feet above the geometric center of the Greenland ice sheet. If you were to look out the window right now, your brain would struggle to comprehend what it was seeing. There is no horizon. There is no separation between the sky above and the frozen earth below. The clouds are white. The ground is white. The light, diffusing through the ice crystals in the atmosphere, is a blinding, uniform white. It is a phenomenon known as sector whiteout, a loss of depth perception so absolute that pilots can't tell if they are flying level, climbing, or diving into the ground without trusting the artificial horizons glowing on their instrument panels. It is claustrophobic. It is disorienting. It is the visual definition of nothingness. Yet, this aircraft is not blind. This modified submarine hunter, once designed to track Soviet vessels deep beneath the Atlantic, has been repurposed by NASA. Its torpedo bays are empty. Its sensors, however, are far more advanced than anything used during the Cold War. The belly of the aircraft is bristling with radar antennas. The wings carry laser altimeters. This is Operation Icebridge. The mission is simple in theory, yet agonizing in execution. Map the invisible. For hours, the flight has been a study in monotony. The aircraft drones on, a tiny speck against the vast indifference of the Arctic Circle. Inside, scientists hunch over banks of glowing monitors. They watch the raw data scroll by in real time. It is a hypnotic cascade of static and lines. A digital heartbeat. Pulse, return, pulse, return. The radar waves are fired downward at the speed of light. They slam into the surface of the ice, penetrate the chaotic layers of snow and fern, and keep traveling. They punch through centuries of accumulation, through the ice of the Industrial Revolution, through the ice of the Middle Ages, through the ice of the last ice age. Finally, 2 miles down, they hit the bedrock, the solid earth. The echo bounces back, racing up through the darkness, through the crushing pressure, back to the receiver on the plane's belly. On the screens, this echo paints a line. For hundreds of miles, that line has been relatively flat, predictable. The bedrock of Greenland is supposed to be a bowl, depressed by the weight of the ice, but generally smooth. Then, the line breaks. A scientist blinks, leaning closer to the monitor. The steady horizontal trace of the bedrock suddenly plunges. It doesn't just dip, it falls off a cliff. On the radar screen, the jagged signature of the Earth drops hundreds of meters in a matter of seconds. Then it stays deep. A valley, a trench, a gorge. The pilots hold their course, fighting the crosswinds. The plane continues its straight line across the whiteout, but the radar below tells a story of violent geography. The bottom of the world has opened up. The scientists watch the data stream. They are seeing something that human eyes have never seen. They are seeing a ghost. As the plane continues, the data reveals the structure is not a crater. It is not a singular hole. It is linear. It winds. It turns. It has tributaries. It has distinct carved walls. The radar signature goes on for 10 miles. Then 50. Then 100. 460 miles. Consider that distance. 460 miles of continuous, uninterrupted scarring in the crust of the Earth. It is a canyon system that dwarfs the imagination. It is longer than the Grand Canyon in Arizona. In places, it plunges half a mile deep into the bedrock. It is a scar of monumental proportions, a geologic leviathan that has been hiding in plain sight for millions of years. Before the ice, this was a river. A massive, thundering artery of water that drained the heart of Greenland out to the sea. It likely teemed with life. It carved its way through the rock over eons, shaped by rain and wind, and the slow erosion of time. Then, the Great Freeze came. The glaciers advanced. The ice thickened, layer upon layer, year upon year, until the sky was shut out forever. The river died. The canyon was buried. The P3 Orion banks, turning at the end of its survey line, its engines groaning under the strain. The crew looks at the screens, silent. They have just confirmed the existence of a mega canyon, a feature so large it should be visible from space. Yet, it is completely invisible to the naked eye. It is a phantom landscape. Below them, right now, under 2 miles of crushing, translucent blue darkness, that canyon still exists. It is perfectly preserved, a time capsule from an epoch before humanity walked the earth. There is no wine down there. There is no light. There is only the unimaginable weight of the cryosphere, pressing down with the force of billions of tons. We have mapped it. We have measured it with radio waves and gravity sensors. We know its depth, its length, and its shape. We can render it in 3D models on our computers. We can fly over it and trace its path from the center of the continent to the coast. But we can never touch it. We can never walk on its rim. We can never climb down its walls. We can never drink from the meltwater that still flows, like a secret vein, along its bottom. It is a geography of the impossible. It is a place that is simultaneously discovered and lost. This is the paradox of the sub-glacial world. We possess the technology to strip away the ice digitally, to peel back the white curtain and stare at the naked rock beneath. We can see the scars. We can see the valleys. We can see the ghosts of ancient rivers. But the physical reality of that place is barred to us. It is protected by a barrier of frozen water so thick, so hostile, and so heavy that it creates a boundary not just of space, but of possibility. The engines drone on, carrying the crew back toward the coast, back toward the world of the living. Behind them, the whiteout swallows the path they traveled. The ice sheet looks exactly as it did before. Flat, featureless, and infinite. It gives no hint of the monster lying in the dark beneath it. Silent, ancient, unreachable. To understand why the valleys beneath Greenland remain so elusive, we must first understand the barrier that protects them. We have to understand the lid. For centuries, the interior of Greenland was not just a blank space on the map. It was a void in the human imagination. Cartographers drew coastline, detailed fjords, and mapped the rocky edges where humanity could cling to life. But the center was left white, a massive, terrifying nothingness. To the Inuit, who had mastered the art of survival on the fringes, the inland ice was the realm of the times. Kivitok, time's spirits of the outcast, wandering the frozen expanse in eternal anger. To the Europeans, it was a riddle wrapped in a death sentence. There was a prevailing theory in the 19th century, a desperate hope, really, that the interior might be green, that behind the wall of ice lay an oasis, a hidden valley of forests and herds, shielded from the Arctic winds by the very glaciers that guarded it. It was a romantic notion, a dream of warmth hidden inside the cold. But the ice does not dream, the ice waits. The year is 1888. A Norwegian scientist named Fridtjof Nansen decides he will be the one to solve the riddle. He is 26 years old, arrogant, brilliant, relentless. His plan is considered suicide by the established explorers of the day. The conventional wisdom for exploring Greenland is to start on the populated west coast and push east, so that if or when things go wrong, you can retreat back to civilization. You can run home. Nansen rejects this. He chooses the opposite. He will land on the savage, uninhabited east coast and walk west. There will be no retreat. There will be no ship waiting to pick him up if he turns around. The only way to survive is to cross the entire ice sheet to the other side. His motto for the expedition is simple, terrifying, and absolute. Death or the West Coast. Death or the West Coast. He arrives in a small sealing ship, aiming for the jagged shoreline. But the ice is not welcoming. Nansen and his team of 5 are forced to leave the ship and board small boats, navigating the chaotic drift ice. For days, they are trapped on an ice floe, drifting south, away from their target, helpless against the current. The ocean churns, the ice grinds, the wind screams. They are nearly crushed, nearly drowned, before they even set foot on the mainland. When they finally scramble onto the rocky shore of Umivik, the season is already turning. It is August. The summer sun is fading. The brief window of safety is closing. They look up. Ahead of them looms the barrier. It is not a gentle slope. It is a chaotic, fractured wall of glaciers, rising steeply into the clouds. Nansen gives the order. They start to climb. He drives his skis into the hard pack. The wood groans. The air is thin, sharp, and smells of absolutely nothing. There is no scent of pine, no salt spray, no rot, no life, just the smell of cold. Clean, sterile, burning cold. They haul heavy sledges, harnessed like draft animals. The slope is steep. The surface is treacherous. In the lower elevations, the ice is tortured. It is split by crevasses, cracks in the world that drop hundreds of feet into blue darkness. One wrong step, one bridge of snow giving way, and a man is gone. Swallowed, erased. Ropes go taut. Muscles burn. Breath comes in ragged, white plumes. They climb out of the crevasse zone and reach the plateau. And here, the true horror of the inland ice reveals itself. It is not the hidden green valley. It is not an oasis. It is a desert of infinite white. Day after day, the routine is a cycle of agony. They wake in sleeping bags stiff with frost. They melt snow for hours just to get a cup of water. They strap on the skis. They walk. They walk until their legs are lead, until their minds begin to fracture from the monotony. There is no horizon. The sky is white. The ground is white. In the flat light of the overcast days, there are no shadows. You cannot tell if the ground in front of you goes up, goes down, or falls away entirely. You are walking inside a ping-pong ball. Sensory deprivation sets in. Without visual markers, the mind begins to hallucinate. A dark speck becomes a house, a ship, a monster. The sound of the wind becomes a voice. The silence becomes a scream. Nansen expects the interior to be flat, but it keeps rising. They ascend to nearly 9,000 feet. The temperature plummets. It is 45 degrees below zero. At night, inside the tent, the moisture from their breath condenses on the canvas walls and freezes, then snows back down on their faces while they sleep. They are thirsty, always thirsty. The air is so dry it sucks the moisture from their skin, their lips, their lungs. They are walking on billions of tons of water, yet they are perpetually dehydrated. But as they trudge across the roof of Greenland, Nansen realizes something profound, something that will change geology forever. The mountains of the interior are missing. Based on the coastlines, there should be peaks here. There should be valleys. But there is only the dome. The ice has buried everything. It has filled the canyons, smoothed over the summits, and created a perfect, lifeless shield. He realizes that the land below him is not just covered, it is crushed. The weight of this ice is pressing the island down into the mantle of the earth. They are walking over a drowned world. October 1000. 888. Thin, ragged, and ghost-like, Nansen and his men stumble down the western slopes. They reach the Godthab Fjord. They have done the impossible. They have crossed the ice. Nansen returns a hero. He writes books. He lectures. He proves that the crossing can be done. But his journey confirms a bleak reality. The surface is a kill zone. It is a place where human biology is an insult to the elements. And crucially, Nansen's crossing was just a scratch on the surface. He walked times over times the ice. He didn't look times into times it. He confirmed the shield existed. But he couldn't tell us what lay beneath the crushing weight. The valleys, the canyons, the rivers that might flow in the deep dark, they remained a mystery, protected by 3 kilometers of frozen water. Decades pass. The world changes. Horses give way to engines. Canvas gives way to aluminum. The romantic age of exploration bleeds into the age of science. Enter Alfred Wegener. If Nansen was the adventurer, Wegener is the visionary, a German meteorologist and geophysicist. Wegener is famous for a theory that was, at the time, laughed out of every university in Europe. Continental drift, the idea that the Earth's landmasses are moving, drifting like rafts on a liquid sea. To prove his theories, to understand the weather systems of the North Atlantic, and to measure the true thickness of the ice cap, he sets his sights on Greenland. It is 1930, the German Greenland expedition. This is not a dash for glory. It is a siege. Wegener plans to establish a permanent station in the dead center of the ice sheet. He calls it Ismit. Mid-ice. He brings the modern world with him. He brings seismographs to measure the ice thickness using explosions. The first attempt to see the sub-glacial valleys with sound. He brings weather balloons. And he brings a secret weapon. Propeller sleds. Imagine 2 massive skis, mounted with a car engine and a giant aircraft propeller on the back. They look like strange wingless airplanes, designed to glide over the snow, hauling tons of supplies, without the need for dogs or human sweat. It is the triumph of machine over nature, or so he thinks. Nature, it turns out, does not care about German engineering. The expedition is plagued by delays. The sea ice blocks their landing. By the time they are unloading onto the ice cap, it is late. Too late. The propeller sleds, the great hope of the mission, are a disaster. Their engines sputter in the thin air. The snow is too soft, like powdered sugar. The heavy machines sink, their propellers chopping uselessly at the air. One by one they break down. They are abandoned. Steel skeletons left to rust in the white void. The mission is in jeopardy. The team at Ismit, the station in the center of the ice, is digging a cave into the snow to survive the coming winter. They need food. They need fuel. They need paraffin oil to keep the seismographs running, to keep listening to the Earth. Without supplies, they will have to abandon the station, and the science will fail. Wegener makes a choice. It is the same choice Nansen made, but with different stakes. He will not let the science die. The 21st of September 1930. The autumn storms are beginning to howl. The temperature is dropping fast. Wegener gathers a relief team. He, his colleague Dr. Lowe, and a young Greenlander named Rasmus Willemsen load up dog sleighs. They must travel 250 miles into the heart of the storm. They push off. The journey is a nightmare. The snow is deep and blinding. The dogs, exhausted and starving, begin to falter. The cold is a physical weight, pressing down on their shoulders. It is 40 degrees below zero, then 50, then 60. Dr. Lowe's toes turn black. Frostbite. He cannot ski. He has to be carried on the sled, adding to the burden. They are crawling across the roof of the world, fighting for every inch. It takes them 40 days. 40 days of torture. When they finally see the bamboo flag marking Ismit, they are broken men. They have delivered the supplies, but barely enough to matter. They have arrived, but at a terrible cost. Lova is in bad shape. His toes will have to be amputated with a pocket knife. He cannot make the return journey. There is not enough food at the station for everyone to survive the winter. Someone has to leave. Someone has to go back to the coast. The 1st of November, 1930. It is Wegener's 50th birthday. There is a small celebration in the ice cave. They smoke a pipe. They talk of geology, of the drifting continents, of the secrets beneath their feet. The next morning, Wegener prepares to leave. The wind is calm. The sun is a pale, cold disk on the horizon. He is optimistic. He is fit, strong, an experienced polar traveler. He puts on his skis. He is wearing a suit of reindeer skin and windproof anoraks. Rasmus Wilhelmsen, 23 years old, volunteers to go with him. Rasmus drives the sled. Wegener skis ahead. They wave goodbye to the men at the cave. They turn their backs to the station. They shrink into the distance. Two small, dark figures against a continent of white. They become dots. Then they become nothing. They are never seen alive again. The silence returns to the ice sheet. The winter descends with full force, burying the tracks, erasing the evidence. For 6 months, the men at the coast wait. The men at Izmit wait. No one comes. When the relief team goes out the following spring, they follow the trail. 118 miles from the station, they find a pair of skis stuck upright in the snow. A grave marker. They dig. They find Alfred Wegener. He is sewn into his sleeping bag, lying on a reindeer skin. His eyes are open, calm. There is no sign of fear, no grimace of pain. He looks like a man who simply lay down to rest. He died of exhaustion. His heart, strained by the altitude and the endless physical toil, simply stopped beating. He died fully dressed, ready to move, stopped in the middle of a stride. But the mystery deepens. Rasmus Wilhelmsen is missing. Wegener's diary, his notes, the scientific data from the journey they were with Rasmus. The young Greenlander had evidently buried his leader, marked the grave with the skis, and then pressed on, trying to reach the coast with the dogs. Search parties scour the route. They probe the snow. They look for the sled. They look for the diary. They find nothing. Rasmus Wilhelmsen vanished. The ice took him, and it took the data. This tragedy marks the end of an era and the beginning of a hard truth. The surface of Greenland is a barrier that defends itself. It kills those who try to measure it. Wegener managed to detonate his explosions before he died. He managed to get the first crude echoes from the bottom. His data, what survived at the station, proved that the ice was far thicker than anyone imagined, nearly 3,000 meters thick in places. He proved that the land beneath was depressed into a bowl shape. He gave us the first blurry X-ray of the sub-glacial world. But the cost was his life. The surface barrier is not just about the cold. It is about the scale. To explore the valleys beneath, you cannot just walk over them. You cannot just drag a sled. The environment is too hostile, too vast, and too efficient at erasing human effort. Nansen proved you could cross it. Wegener proved you could measure it. But both of them showed that you cannot conquer times it. The ice sheet is a vault. It locks its secrets away. To open that vault, to truly see the canyons and the rivers hiding in the dark, humanity would need to stop fighting the ice on its own terms. We would need to stop walking. We would need to stop skiing. We would need to leave the surface entirely. We would need to look from above. But that technology, the ability to peer through miles of ice from the safety of the sky, was still years away. For the moment, in the 1930s, the White Death had won. The interior remained silent. The valleys remained hidden. The wind howled over Wegener's grave, burying him deeper and deeper with every storm, pulling him down toward the very bedrock he gave his life to discover. The snow falls, the wind screams, and the ice waits. It waits for the next attempt. It waits for the next set of tools. It waits to see if we can invent a way to strip it naked without dying in the process. For now, the valleys sleep. Dark, cold, unknown. The lid is closed tight, but the questions remain. What exactly is times down there? If the mountains are missing, if the center is a bowl, where does the water go? If the ice is melting from the bottom up due to geothermal heat, are there rivers? Are there lakes? Is there a catastrophic flood waiting to happen? Wegener's death was a warning. The ice keeps its own counsel. It does not give up its history easily. To understand the subglacial valleys, we have to look at what happened next. We have to look at the moment when war, of all things, turned the Arctic into a strategic chessboard, when the need to hunt submarines and hide nuclear missiles inadvertently gave us the keys to the kingdom. But before the radar, before the satellites, there was only the man on the skis, the sound of his breath, the creak of the leather binding, and the terrifying, beautiful, infinite white, a white that cleanses, a white that buries, a white that endures. Alfred Wegener lies there still, encased in the glacier, drifting slowly, inch by inch, year by year, toward the sea. He is part of the ice now. He is part of the barrier, and his silence speaks louder than any data point. It tells us that the subglacial world is not a place for tourists. It is a place that demands a toll. If we want to see what is hidden, we have to be willing to pay it. Or we have to find a way to cheat, to see without touching, to explore without entering. This is the challenge of the 20th century. This is the hurdle of the surface barrier. And as the 1930s fade into the chaotic rumble of the 1940s, the approach to Greenland is about to change. We stop sending heroes. We start sending waves. Radio waves. But the memory of the early crossings remains. It remains a testament to the sheer physical reality of the blockage. It reminds us that underneath the graphs and the satellite images we see today, there is a physical reality of cold so intense it stops the heart. The map is not the territory. The map is safe. The territory is lethal. And that territory, that white expanse, is the lid on the coffin of the ancient world. To pry it open, we will need more than courage. We will need a new kind of eye. The wind on the Greenland ice sheet does not just blow, it scours. It is a physical weight, a relentless pressure that seeks to erase anything standing vertical in a horizontal world. In 1959, the United States Army Corps of Engineers steps into this void. They bring with them the confident, industrial swagger of the mid-28th century. They have conquered the atom, they have conquered the skies, and now they intend to conquer the ice. They do not come to build a base times on times the glacier. That would be too vulnerable, too exposed to the brutal storms and the prying eyes of Soviet satellites. They come to build a base times inside times it. The plan is audacious. It borders on madness. It is the height of Cold War paranoia, manifest in snow and steel. The public cover story is innocent enough. A scientific research station to test construction techniques in polar environments. A laboratory for the future. They call it Camp Century. But beneath the press releases and the smiling photos of soldiers in parkas lies a darker, secret purpose. The Pentagon calls it Project Iceworm. The goal is not science. The goal is deterrence. The military strategists in Washington look at the globe and see Greenland not as a sovereign territory or a natural wonder, but as a launch pad. It is strategically perfect. If they can burrow into the ice sheet, they can hide up to 600 nuclear missiles, 600 Iceman missiles, constantly moving on a subterranean railway network, invisible, invincible, always within striking distance of the Soviet Union. To prove it can be done, they must first build the prototype. They must build the city under the ice. The construction begins not with shovels, but with Swiss plows. Massive, roaring machines known as Peter snow millers, are shipped to the edge of the ice cap. These machines are monsters of industry, capable of chewing through tons of compacted snow and blasting it high into the air. Watch them work. The engine roars, a mechanical scream against the howling wind. The giant rotary blades spin, biting into the white surface. They do not dig down. They cut straight ahead, carving deep, open trenches into the glacier. The soldiers operating them are wrapped in layers of wool and synthetic fur, their breath steaming up their goggles. They work in shifts, fighting the cold, fighting the fatigue. 24 feet wide, 24 feet deep. The trenches stretch out like open wounds in the ice. Once the trench is cut, the frantic work of covering it begins. Corrugated steel arches are lowered over the top, creating a curved roof. Then the snow millers return. They blast the excavated snow back over the steel arches. The snow settles. It hardens. In hours it becomes as hard as concrete. The trench is gone. From the surface, there is nothing but a flat, white expanse. But underneath, a tunnel has been born. This is the cut and cover method. It is efficient. It is brutal. It allows them to construct a sprawling network of 21 tunnels, a subterranean labyrinth totaling nearly 2 miles in length. Inside these steel-ribbed tunnels, they build the city. Prefabricated wooden buildings, plywood boxes, painted in bright, cheerful colors, are slid into place. There are barracks, there is a mess hall, there is a laundry, there is a barber shop. They build a chapel with a simple cross. They build a movie theater. They build a library. It is Main Street, USA, transplanted 4,000 miles north and buried 30 feet under the surface. To power this frozen metropolis, they do not rely on diesel generators alone. The logistics of hauling fuel across the ice sheet are a nightmare. Instead, they bring the fire of the atom, the PM2, a nuclear reactor. It arrives in pieces, dragged on heavy sleds across the treacherous ice by tractor trains. It is the world's first portable nuclear power plant. The technicians assemble it with surgical precision in the deepest, largest cavern of the complex. The control rods are inserted. The core goes critical. Heat floods the station. Suddenly, the temperature inside the tunnels rises. It is no longer 40 below zero. It is comfortable. Soldiers walk from their barracks to the showers in t-shirts. There is hot water, endless hot water. There is electricity to run the popcorn machine in the theater and the bright fluorescent lights that banish the polar darkness. It feels like a triumph. For the men stationed there, life settles into a surreal rhythm. They wake up in darkness. They eat breakfast under artificial lights. They work their shifts repairing engines or monitoring the reactor. And then they go to the rec room to play pool. They are living inside a glacier, yet they are insulated from it. They are warm, they are fed, they are safe, or so they believe. But the ice is not rock. This is the fundamental misunderstanding, the fatal flaw in the hubris of Project Iceworm. The engineers treat the glacier as a solid foundation, a static medium like dirt or granite. But a glacier is a river. It is a slow-moving, heavy, relentless river of ice. It flows, it deforms, it breathes. The weight of the ice sheet is unimaginable. Millions of tons of pressure bear down on the empty spaces carved by the snow millers. The laws of physics demand that the void be filled. The term is viscoelastic flow. It is a dry, scientific term for a terrifying reality. The walls begin to close in. It starts slowly. A creak in the night, a subtle bending of a steel arch. The soldiers notice that a door frame is no longer square. A shelf starts to tilt. The measurements are taken. The tunnels are shrinking. The floor rises to meet the ceiling. The walls press inward. The steel arches, designed to hold back the weight of the snow, begin to buckle. They groan under the strain, the metal twisting like taffy. The maintenance crews shift from construction to survival. They become ice trimmers. Every day, Teams of men go out into the tunnels with chainsaws and picks. They must shave away the encroaching walls. They cut back the ice that is trying to swallow their city. It is a losing battle. Imagine the sound. The deep, resonant cracking of the glacier. It echoes through the plywood walls of the barracks. It is the sound of the planet rejecting the intruder. The ice moves at a rate of over 3 feet per year. In some places, that doesn't sound fast. Until you are living inside a box with only inches of clearance. The reactor cavern suffers the most. The heat from the nuclear plant, the very thing that makes life possible, is accelerating the deformation. The ice softens, it creeps faster. The floor under the reactor begins to tilt. This is catastrophic. A nuclear reactor requires perfect alignment. It requires stability. It cannot function if the ground beneath it is twisting. The dream of Project Iceworm begins to fracture. The generals in Washington read the reports. The dream of 600 missiles shuttling through thousands of miles of tunnels dissolves. If they cannot keep a small research station from being crushed, how can they possibly maintain a railway system the size of a European country? The maintenance alone would require an army of thousands doing nothing but cutting ice forever. The cost is too high. The physics are too undeniable. But amidst the failure, there is a strange, accidental success. A team of scientists, led by a Danish researcher named Willy Dansgaard, uses the deep access of Camp Century to drill down. They drill not for missiles, but for history. They extract the first deep ice core. A long, translucent cylinder of ice is pulled from the borehole. It is ancient. It contains bubbles of air trapped thousands of years ago. By analyzing the isotopes in the ice, they can read the climate history of the Earth. They discover that the climate can change rapidly, violently. They discover the secrets of the past, locked in the frozen layers. The military wanted a weapon. The scientists found a library. It is a profound irony. The cover story becomes the legacy, but the base itself is doomed. By 1964, the reactor is becoming dangerous. The deformation is severe. The walls are closing in. The steel arches are deformed beyond repair. The city under the ice is being slowly, methodically strangled. The decision is made. Evacuate. They cannot take everything. The reactor is the priority. The highly radioactive core is removed, shielded, and shipped back to the United States. They take the sensitive equipment. They take the personal effects, but they leave the rest. They leave the buildings. They leave the furniture. They leave the diesel generators. They leave the sewage sumps, filled with years of human waste. They leave thousands of barrels of low-level radioactive coolant frozen into the ice. They leave the heavy machinery, the trucks, the steel. The logic is simple, based on the understanding of the time. The ice is eternal. The snow will continue to fall. The base will be buried deeper and deeper. It will be entombed forever, preserved in a deep freeze, harmless and forgotten. The solution to pollution is dilution, they say, or in this case, burial. The lights are turned off. The heavy blast doors are sealed. The last transport pulls away, leaving the ventilation stacks sticking out of the snow like tombstones. The year is 1967. Camp Century is abandoned. Silence returns to the ice sheet. The wind continues to scour. The snow continues to fall. Slowly, the weight of the new snow pushes the tunnels down. The steel arches finally collapse. The plywood buildings are crushed into splinters. The mess hall, the chapel, the theater, they are all flattened, compressed into a layer of debris deep within the glacier. The city is gone, but it is not gone. It is merely waiting. The engineers calculated the snowfall. They calculated the flow of the ice, but they did not calculate the warming of the world. They assumed the ice sheet would grow, or at least remain stable. They did not foresee a future where the melt would outpace the snow, decades pass. The Cold War ends. The Soviet Union falls. The fear of nuclear annihilation fades, replaced by new anxieties, and in the silence of the Arctic, the ice sheet begins to change. The surface lowers. The meltwater runs in rivers. The tomb of Camp Century is getting closer to the surface, year by year. The thousands of tons of biological waste, the PCBs, the radioactive coolant, the diesel fuel, it is all still there, sitting, waiting. What was meant to be buried forever is now a ticking clock. Project Iceworm was a failure of military strategy, but it was a triumph of human engineering capability. We proved we could build a city inside a glacier. We proved we could live there, but we also proved that we could not beat the ice. We fought the glacier, and the glacier won. The wreckage of Camp Century serves as a monument to a specific kind of mid-century arrogance, the belief that with enough concrete, enough steel, and enough atomic power, we could bend nature to our will. We treated the Greenland ice sheet as a blank canvas, a neutral space to project our fears and our ambitions. But the ice is not neutral. The ice is active. It is powerful, and it has a long memory. When we look back at the black and white footage of the soldiers laughing in the subterranean mess hall, or the Peter Snow Miller throwing arcs of white powder into the sky, we are looking at ghosts. We are looking at men walking inside the belly of a beast they did not understand. They thought they were building a fortress. They were digging a grave. And now, let us move deeper, away from the human attempts to colonize the ice, and into the ice itself. Because while the soldiers were worried about the Russians, and the engineers were worried about the tunnel walls, something else was happening beneath their feet. Something far more ancient and far more mysterious. The valleys, the radar scans that revealed the perfect hiding spots for missiles, also revealed something else. They revealed a landscape hidden from the sun for millions of years. A ghost landscape. Imagine stripping away the ice. All of it. All 660 quadrillion tons of it. What is left? It is not a flat, barren rock. It is a canyon that rivals the Grand Canyon in scale. It winds its way from the center of the island all the way to the northern coast. It is huge, it is deep, and it is completely invisible to the naked eye. The Mega Canyon. It was there before the first snowflake fell. It was there when Greenland was green. It was there when forests covered the land, and rivers rushed through the valleys. To understand why we cannot truly explore these valleys, we have to understand the sheer scale of the barrier. The ice at Camp Century was a few thousand feet thick. The ice over the Mega Canyon is 2 miles thick. 2 miles. Think of the pressure. At the bottom of the ocean, we have built submarines to withstand the crushing weight of the water. But water is fluid. Ice is solid. The pressure at the base of the Greenland ice sheet is enough to warp rock. It creates a strange, alien environment where water can exist in a liquid state. Simply because the pressure is so intense, it lowers the freezing point. Sub-glacial lakes. These are not like the lakes we know. They are pockets of water, sealed off from the atmosphere for eons. They are time capsules. They might harbor microbial life that has evolved in complete isolation, cut off from the rest of the planetary ecosystem for millions of years. But reaching them, that is the problem. Project Iceworm taught us that digging into the ice is a temporary act. The ice heals itself. It fills the void. If we were to drill a shaft down to the canyon floor, 2 miles down, the walls would not just close in. They would collapse almost instantly, without massive reinforcement. And the heat. Drilling creates friction. Friction creates heat. Heat melts ice. To drill down to the subglacial valleys is to risk contaminating them. As soon as you breach that seal, you introduce the surface world. You introduce bacteria, oxygen, chemicals, you destroy the very thing you are trying to study. It is the observer's paradox on a geological scale. You cannot touch the pristine environment without ruining it. So, the valleys remain a mystery. We see them only through the eyes of radar. We bounce radio waves off the bedrock and measure the echo. We paint a picture with sound. We know the shape of the cliffs. We know the depth of the gorge. We can trace the path of the ancient river that once flowed there, but we cannot walk there. We cannot stand on the banks of that buried river. The ice keeps its secrets. Camp Century was a scratch on the surface, a flea bite on the back of a giant. The mega canyon is the spine of the giant. We often talk about space as the final frontier. We look to Mars, to Europa, to the stars. But there is a frontier right here, beneath our feet, that is just as inaccessible, just as hostile, and just as alien. The Grand Canyon of Greenland sits in eternal darkness. Above it, the ice sheet shifts and groans. Above that, the wind howls, and above that, the satellites pass silently, mapping a world we can see but cannot touch. The failure of the city under the ice was a warning. It told us that we are guests here, temporary, fragile guests. The ice allows us to pass, perhaps. It allows us to scratch the surface, but it does not allow us to stay, and it certainly does not allow us to conquer. The wreckage of the base moves slowly toward the coast. In a few decades, or perhaps a century, the glaciers will calve. The icebergs will break off and float into the ocean, and embedded in one of those icebergs, like a fly in amber, will be the twisted remains of a nuclear reactor control room, or a crushed plywood wall, painted a cheerful yellow, a message from the past, delivered to the future. We were here, it will say. We tried, and the ocean will swallow it, just as the ice did. But until then, the research continues. Not with missiles, but with sensors. We listen to the ice. We measure the melt. We watch the water run off the surface, blue and cold, rushing into the moulins, diving deep into the plumbing of the glacier. Where does that water go? It goes down, down through the cracks, down through the miles of darkness, down to the bottom. It greases the tracks. This is the newest realization, the modern sequel to the iceworm story. The meltwater from the surface is reaching the bedrock. It is lubricating the connection between the ice and the rock. It is making the glaciers slide faster. The ice is not just moving, it is accelerating. The very climate change that threatens to expose Camp Century is also speeding up the flow of the ice into the sea. It is a feedback loop, a cycle of destruction. The water reaches the subglacial valleys. It rushes through the hidden canyons. It flows along the ancient riverbeds, a ghost river resurrected by a warming world. We can't explore these valleys with our bodies, but our pollution has already found a way in. Our carbon, warming the air, melting the snow, sending the water down. We are touching the bottom of the world, not with our hands, but with our consequences. The story of the subglacial valleys is not just a story of geology. It is a story of connection. The top of the ice is connected to the bottom. The actions of the 1960s are connected to the environmental crises of the 2020s. The military ambition is connected to the scientific reality. Everything is linked, and at the center of it all, silent and white, lies the ice. It is indifferent to our politics. It is indifferent to our fears. It obeys only the laws of physics. Gravity, pressure, friction, temperature. It is the ultimate arbiter. We look at the map of Greenland. We see the white expanse. We now know what lies beneath. We know about the canyons, the lakes, the crushed city. We know the history. But knowing is not the same as controlling. Project Iceworm was the ultimate attempt at control. It failed. And so, the valleys remain. Dark, silent, waiting. They are the last places on Earth that are truly alone. For now. But let us pause and consider the human element one last time. Think of the young soldier, 18 or 19 years old, drafted from a farm in Iowa or a suburb in Ohio. He is sent to the top of the world. He descends into a hole in the ice. He sleeps in a wooden box buried under tons of snow. He walks to the mess hall, smells the coffee, hears the jukebox playing rock and roll. Does he feel the weight? Does he feel the millions of tons of ice pressing down from above? Does he sense the slow, grinding movement of the glacier? Or does he just feel the cold? He writes letters home. He tells his parents he is safe. He tells them, it's amazing, this city, under the ice. He sends a picture of himself standing next to a wall of snow. He smiles. He doesn't know about the deformation measurements. He doesn't know the reactor floor is tilting. He doesn't know that in 60 years, climate scientists will be debating how to clean up the mess he is helping to make. He is just doing his job. Rape, check. Murder, check. Burglary, check. No, that's not right. Those are the crimes of the city. Times above, times ground. The crimes of the city, times below, times ground are different. Hubris, check. Ignorance, check. Destruction, check. The crimes against nature are quieter. They don't make the evening news. They happen slowly, over decades. A slow leak of radiation, a slow seep of diesel, a slow collapse of a tunnel. The victim is the ice. But the ice is also the executioner. It is a complex relationship, a dance between the fragile human ego and the immovable geological force. As we move forward in this documentary, as we leave the ruins of Camp Century behind and travel deeper into the science of the subglacial world, keep that image in your mind. The image of the crushed city. It is a warning. If we cannot maintain a few tunnels for a few years, how can we hope to understand a landscape that has been buried for 1,000,000 years? We are small. The ice is big. That is the lesson. That is the only lesson that matters. And as the wind howls over the abandoned site, burying the ventilation stacks once and for all, the ice sheet keeps its counsel. It holds the city in its cold embrace, tight, tighter, until there is no space left, until there is only ice. Only ice. The story of Project Iceworm is closed. But the story of the ice is just beginning. Let's look at what the ice is hiding. Not the mistakes of men, but the masterpieces of nature, the hidden mountains, the buried lakes, the landscapes that no human eye has ever seen. These are the true subglacial valleys, and they are calling to us, but we cannot answer. We can only listen. The radar pings, the satellites orbit, the data streams in. We build our models. We draw our maps. We dream of what it looks like down there. Is it beautiful? Is it terrifying? Is it silent? Yes. It is all of those things. It is the unseen world, the shadow, Greenland, and it will remain so, because to see it, truly see it, we would have to destroy it, and we have destroyed enough. The wind picks up again. The whiteout returns. The coordinates of Camp Century disappear into the blizzard. The city sleeps. The valley waits. The ice moves. It always moves. Imagine a silence so absolute it has weight. A silence that presses against the eardrums, heavier than water, older than history. This is the silence of the central Greenland ice sheet. To the naked eye, standing on that frozen plateau, the world is a featureless void. It is a flat, blinding expanse of white that stretches to a curved horizon, broken only by the wind and the shifting drift. It looks perfect. It looks solid. It looks empty. But this is a lie. Beneath your feet, buried under 2 miles of crushing ice, the earth is screaming. It is twisted, gouged, and scarred. And for decades, we walked upon this ceiling of ice, completely unaware of the cathedral hidden in the basement. We assumed the land below was a bowl, a flat, depressed basin crushed by the weight of the glacier. We were wrong. For 40 years, a ghost was hiding in the data, a geological monster sleeping in the static of old radar tapes. The story of the Ghost Canyon isn't just about a hole in the ground. It is about the blindness of exploration. It is about how we look at a map and see what we expect to see, rather than what is actually there. The year is 1970. The Cold War is freezing the geopolitics of the world, just as the ice freezes the north. But in the sky above Greenland, a different kind of mission is underway. A C-130 Hercules transport plane, a lumbering beast of metal and noise, claws its way through the thin polar air. It is not carrying bombs. It is carrying ears. Technicians inside the fuselage are huddled over glowing oscilloscopes. The cabin smells of aviation fuel, stale coffee, and ozone. They are flying blind, relying on a technology that is still finding its legs. Radio echo sounding. The concept is simple. Even if the execution is a nightmare of engineering, the plane blasts a pulse of radio waves downward. The waves ignore the air. They slam into the ice. Most of the energy keeps going, traveling through the frozen water as if it were glass. But when that wave hits the bedrock at the bottom, the actual dirt and stone of Greenland, it bounces back. Ping, echo. The time it takes for the echo to return tells the scientists how thick the ice is. It allows them to draw a line, a profile of the bottom, but the data is messy. In the 1970s, there is no GPS to pinpoint the plane's location to the inch. Navigation is done by inertial systems and celestial observation. The plane drifts. The radar waves scatter. The bedrock below is rough, creating clutter. On the screens, ghostly shapes that look like mountains 1 second and vanish the next. The flight lines are sporadic. They are straight lines drawn across a chaotic wilderness. Imagine trying to map the streets of London by driving a single car in a straight line from north to south. Once, in the dark, you would see a slice of a building, a patch of road, a flicker of a park. You would not see the city. You would not see the connections. Throughout the 1970s and into the 1980s, these flights continued. The Technical University of Denmark, the National Science Foundation, the British Antarctic Survey, they flew their lines. They recorded their echoes. They spooled miles of magnetic tape and printed thousands of feet of film. And then they filed them away. The data was fragmented. It was a jigsaw puzzle with 90% of the pieces missing. On the maps drawn in the 1990s, the center of Greenland was depicted as a relatively smooth basin, a shallow depression where the ice had pushed the crust down. Safe, predictable, boring, but the ghost was there. If you looked at the raw data from 1975, you saw a dip, a deep, jagged V shape in the bedrock. If you looked at a flight from 1993, 100 miles away, you saw another dip, a terrifyingly steep gorge. If you looked at a NASA track from 2001, there it was again, a canyon floor, plunging below sea level. But because these were isolated pinpricks in a vast void, nobody connected them. They were seen as local anomalies, just a hole here, a valley there, a glitch in the matrix. The human mind craves patterns, but it struggles to build them across 4 decades of incompatible data formats. Analog film, digital tapes, Excel spreadsheets. The evidence was scattered in university basements and government servers across 3 continents. The canyon remained hidden in plain sight. Then came the turning point. The realization that the ice sheets were dying. As the 21st century broke, the climate began to shift. Greenland was melting. The world needed to know how much, how fast, and where the water was going. You cannot understand the flow of the ice if you do not understand the shape of the pipe it flows through. Enter Operation Ice Bridge. NASA needed to bridge the gap between 2 satellite missions. They couldn't wait for the next orbiter to launch. They had to get back in the air. They retrofitted a P-3 Orion, a submarine hunter, a plane designed to listen for the subtle turn of a Soviet propeller deep underwater, was now tuned to listen for the echo of stone deep under ice. The P-3 Orion is a visceral machine. It is loud. It vibrates with a bone-shaking frequency. Inside the plane, the atmosphere is tense but monotonous. The mission creates a strange kind of fatigue. The pilots are flying, mowing the lawn patterns back and forth, over the blinding white nothingness. He pushes the throttle. The engines drone. The radar pulses. Ping. Echo. Ping. Echo. It is 2010. The technology has evolved. The radar is now a multi-channel coherent radar depth sounder. It creates a curtain of data, slicing through the ice sheet like a scalpel. And as the P-3 flies over the northern interior, the scientists watching the monitors begin to see something disturbing. The floor drops out. 1 minute, the bedrock is a mile down. The next, it plunges. The radar trace on the screen dives, revealing jagged walls that tower thousands of feet in the dark. Then, just as quickly, the floor rises again. They have crossed a trench. 10 minutes later, on the return leg, they cross it again. Deeper, wider, 50 miles north. They cross it again. It is relentless. The flight paths are stitching together a wound in the earth that refuses to heal. But even then, amidst the roar of the engines and the smell of hot electronics, the full scale isn't obvious. They are seeing cross-sections. They are seeing slices of bread, not the whole loaf. It would take a different kind of excavation to reveal the monster. Not an excavation of ice, but an excavation of data. Jonathan Bamber, a glaciologist at the University of Bristol, takes on the impossible task. He and his team aren't just looking at the new ice bridge data. They are going dumpster diving into history. They are gathering the ghosts. They pull the dusty tapes from the 1970s. They digitize the film from the 1980s. They align the mismatched coordinates of the 1990s. They take millions of radar pulses, collected by dozens of different planes over 40 years, and they throw them into a single supercomputer simulation. They tell the computer, connect the dots. The algorithm begins to work. It looks at the elevation of the bedrock here and the elevation there. It looks for the path of least resistance. Water flows downhill, even under ice. The laws of physics apply. The computer looks for the hydraulic potential. It searches for a channel. Slowly, on the screen, the image resolves. The random holes align. The isolated valleys connect. The confusion vanishes, replaced by a terrifying clarity. It wasn't a series of holes. It was a river, a single, continuous, serpentine gash running from the deep interior of Greenland all the way to the northern coast. The scale of the revelation, published in 2013, shocks the scientific world. We thought we had mapped the Earth. We thought the age of great geographical discovery ended with Shackleton and Amundsen. We were wrong. We had missed a feature the size of a country. They call it the Mega Canyon. Let's trace the spine of this beast. It begins near the center of the ice sheet, the deep, silent heart of the island. It winds northward, carving a tortuous path through the bedrock. It is 460 miles long. Let that sink in. 460 miles. That is longer than the Grand Canyon in Arizona. It is 50% longer. If you were to drive it at highway speeds, it would take you 7 hours to traverse if there were a road. But there is no road. There is only the crushing weight of the glacier. The depth is equally staggering. In places, the canyon plunges 2,600 feet down. That is nearly half a mile of vertical rock wall, buried under 2 miles of vertical ice. Imagine standing at the bottom. Remove the ice for a moment. Strip away the white blanket. What do you see? You are standing on a riverbed that hasn't seen the sun in 4 million years. The walls rise up on either side of you, sheer cliffs of ancient crystalline shield rock, dark and jagged. The silence here is different. It is the silence of a tomb. Above you, where the sky should be, there is a ceiling of ice. It presses down with a pressure of millions of tons. It grinds against the rim of the canyon, but down here, in the V-shaped notch, the water flows. This is the canyon's secret function. It is the plumbing system of northern Greenland. Meltwater from the surface trickles down through cracks and moulins. It journeys through a mile of darkness until it hits the bedrock, and then it finds the canyon. The Ghost River is flowing today, a sub-glacial torrent, rushing through the dark, carrying silt and gravel, greasing the underside of the ice sheet, speeding its slide toward the ocean. But looking at the map Bamba and his team created, we see something even more haunting. We see the past. The shape of the canyon is distinct. It winds. It meanders. These are not the brutal, straight lines gouged by a glacier. Glaciers are bulldozers. They crush and flatten. This canyon twists like a snake. That means it was made by water. Liquid water. It means that before the ice came, before the eternal winter settled on Greenland 3 or 4 million years ago, this was a major river system. Close your eyes and picture it. 3 million years ago. The air is crisp, but not freezing. The sky is a pale, clean blue. A massive river, wide and powerful, roars through the northern tundra. Its banks are lined with boreal forests, pine trees, spruce, birch. There is life here. Maybe the distant call of an early ancestor of the wolf, the rustle of a small mammal in the underbrush. The water sparkles in the sunlight, flowing north to the Arctic Ocean, which is free of sea ice in the summers. This canyon was alive. It was the artery of a vibrant ecosystem. Then, the temperature dropped. The snow began to fall, and it didn't melt. Year after year, layer after layer. The snow compressed into ice. The glaciers grew in the highlands and began their slow, relentless march. They filled the valleys first. The river was choked off. The water froze. The ice thickened, rising higher and higher until it overtopped the canyon walls. It buried the pine trees. It buried the soil. It buried the sound of the rushing water. For millions of years, the canyon was forgotten. It became a ghost. The discovery in 2013 changed everything about how we understand the ice sheet. We realized that the ice isn't just sitting on a flat table. It is draped over a complex, rugged landscape that actively interacts with it. The canyon protects the ice, in a way providing a stable channel for water, but it also threatens it, allowing the ocean to reach deep inland if the ice retreats. But the most profound realization is one of humility. We live in an age of satellites that can read a license plate from space. We have mapped the surface of Mars more accurately than we have mapped the floor of our own oceans. And yet, on a landmass inhabited by humans, just a few hours' flight from New York or London, a 460-mile-long scar in the Earth lay undiscovered until yesterday. The Ghost Canyon is a reminder of the void. It reminds us that the ice is a shield. It deflects our gaze. Radar is a miraculous tool, but it is still just a flashlight beam in a pitch-black room. We see the strip of floor we illuminate. But the darkness around it remains absolute. Even now, knowing it is there, we cannot truly explore it. We can see the ghostly outline on a computer screen. We can trace the path with a mouse cursor, but we cannot go there. We cannot send a rover. The terrain is too rugged. The interface between ice and rock too chaotic. We cannot drill a shaft large enough to send a human. The ice moves. It shifts and shears. A tunnel would be crushed in days. We cannot send a submarine. There is no open water, only a pressurized film of sludge and liquid rushing through the dark pores of the canyon floor. It is a place on Earth that is strictly off-limits to Earthlings. The 460-mile void is a paradox. It is mapped, yet unknown. It is real, yet invisible. As the data from Operation Icebridge was compiled, filling in the gaps of the 1970s, the map became a testament to persistence. It took 4 decades of flights. It took thousands of flight hours. It took pilots risking their lives in polar storms. It took scientists staring at static until their eyes watered. And what they found was a system of majesty that rivals the greatest natural wonders of the world. Yet it will never appear on a tourist brochure. No guardrails will ever be built on its rim. No photos will ever be taken of its sunrise. It exists entirely in the dark. The radar eyes continue to fly. The P3 Orion, and now the newer satellites, continue to sweep the ice. Every pass refines the image. We are sharpening the focus on the ghost. We are learning the texture of the canyon floor. We are measuring the volume of the water flowing through it. But the mystery remains. What lies in the sediment at the bottom of that canyon? If the river flowed for millions of years before the ice, the bottom must be lined with the history of a green Greenland. Pollen grains, fossilized wood, perhaps the remains of life that existed before the big freeze. All of it sealed in a vault of stone, locked under the weight of the cryosphere. The discovery of the Ghost Canyon forces us to look at the white expanse of Greenland differently. When you see that flat horizon now, you don't see emptiness. You feel the depth. You sense the architecture beneath the facade. You realize that the ice sheet is not a solid block. It is a veneer, a mask hiding an ancient, tortured face. The void is not empty. It is full of secrets. And the silence of the central ice sheet is not a silence of absence. It is the silence of holding one's breath. The canyon is down there, waiting. It was there before us. It will be there after the ice is gone. For now, it remains the exclusive property of the radar waves. A phantom geography, a ghost canyon flowing through the eternal night. The data had finally spoken. The 460-mile anomaly was real. But just as the scientific community began to grapple with the implications of this mega canyon, the ice sheet had one more surprise to reveal. Something even stranger. Something that wasn't carved by water, but born from fire. Because while the canyon told the story of what happened times before times the ice, the next discovery would hint at what might be happening times during times the ice. The radar had found a river. Now, it was looking for a heat source. Deep in the northeast, the sensors were picking up something that shouldn't be there. The echoes were warping. The layers of the ice were melting from the bottom up, but not from the friction of movement. They were melting from a localized hotspot, a thermal anomaly that defied explanation. The canyon was a tomb. This was a furnace. But to understand the fire, we have to go back to the darkness. We have to go back to the pilots flying those endless grid lines, watching the screens, and realizing that the Ghost Canyon was just the beginning of the unknown. Word count check. The narrative creates a complete arc for the Ghost Canyon section, establishing the history, the methodology, the scale, and the implications, while setting up a transition to the next potential section about geothermal anomalies. It utilizes the sensory details of the flights and the visualization of the subglacial environment. The immense length of the canyon, 750 kilometers or 460 miles, dominates the narrative. It is the anchor. The discovery by Bamber et al. In 2013 provides the climax. But the meat of the section is the long, slow struggle to see through the blindfold of the ice. Let's deepen the human element within the cockpit scenes to ensure the word count and emotional resonance are maximized. The pilots of the P3 Orion are not just drivers, they are tightrope walkers. Flying low over the ice sheet is hypnotic. The phenomenon is called sector whiteout. The contrast vanishes. The sky and the ice merge into a milky bowl. You lose your sense of up and down. You have to trust the instruments implicitly. Inside the tube, the scientists are fighting motion sickness. They are staring at scrolling displays, waterfall charts that show the radar return in real time. It looks like a gritty, black and white ultrasound of a giant. Every time the plane banks, the radar sweeps a new angle. They are painting the picture, stripe by stripe. Bank left. Maintain 1,500 feet. The voice in the headset is calm. The reality is chaos. The discovery of the Ghost Canyon wasn't a eureka moment in a lab where someone jumped out of a bathtub. It was a slow burn realization. It was the result of staring at a screen for 10 years and saying, "That doesn't look right." It was a victory of patience. In the 1990s, when the data was sparse, they called these areas the zone of confusion. Maps from that era simply left the area blank or interpolated a flat line. They smoothed over the error. They erased the canyon because it didn't fit the model. This is a critical lesson in science. The outlier is often the discovery. The data point that ruins your graph is usually the one that tells the truth. The canyon ruined the graph of the flat bedrock. It broke the model. And in doing so, it revealed the truth of the landscape. We must also consider the void in terms of time. The canyon connects us to the Pliocene epoch. It connects us to a world without an ice cap. By mapping it, we are not just exploring space. We are exploring time. We are seeing the ghost of the greenhouse world that existed before the icehouse world, and perhaps the world that is coming again. If the ice melts, if the Great White Dome collapses, the canyon will emerge. The Ghost Canyon will become a real canyon. The sun will strike those black rocks again for the first time in 3 million years. The river will roar in the open air, but until then, it is ours only in the abstract. It is a string of zeros and ones on a hard drive in Bristol. It is a squiggly line on a chart. It is 460 miles of mystery, wrapped in cold, wrapped in silence, wrapped in the dark. The radar sees it. We know it is there. Structure check. 1. Intro. The silence and the deception of the surface. 2. 1970s. The crude beginning. C. 130S and film. 3. The gap. The fragmentation of data. The zone of confusion. 4. The shift. Operation Icebridge. The P3 Orion sensory experience. 5. The analysis. Bamba's team stitching the quilt. 6. The reveal. 460 miles. The scale comparison. 7. Visualization. The pre-glacial river. The trees. 8. The unreachable. Why we can't go there. 9. Conclusion. The phantom geography. This structure is robust. The pacing moves from the slow, confused past to the urgent, high-tech present, and settles into a contemplative, deep-time reflection. Let's add a specific detail about the false bottom. In the early days of radar, the signal would sometimes bounce off internal layers of ice, layers of volcanic ash, from ancient eruptions, and the scientists would think that was the bottom. They were mapping the ghosts of volcanoes, thinking it was the floor. It took better frequencies to punch through that and find the true canyon floor below. This adds to the ghost motif. Also, emphasize the rule of 3 in the description of the canyon's path. It winds, it twists, it flows. Pine, birch, and spruce. The dark, the cold, and the pressure, final polish on the transition. The canyon was a tomb. This was a furnace. This sets up the next act perfectly while concluding the current thought. The resulting script will be dense, atmospheric, and strictly adhering to the show don't tell mandate by describing the process times of seeing rather than just the result, proceeding to output the final text block. The silence of the Greenland ice sheet is a lie. From a distance, from the safety of a satellite feed or a high-altitude flight, it looks static. A white shroud frozen in time. A locked vault. But stand on the surface in July and the silence breaks. It trickles. It gurgles. It roars. We are standing on the western flank of the ice sheet. It is summer. The sun does not set. It simply circles the horizon, a relentless, unblinking eye that refuses to let the ice sleep. The temperature hovers just above freezing. 1 degree, 2 degrees. It is enough. Everywhere you look, the surface is sweating. Millions of tiny pores in the fern open up. Individual crystals of ice, compacted over 10,000 years, surrender their bonds. They turn to liquid. A single drop joins another, then another. They follow the microscopic topography of the ice, finding the path of least resistance. Grooves become runnels. Runnels become brooks. Brooks become impossible. Sapphire blue rivers rushing over a landscape of blinding white. This is the beginning of the dark river. It does not start in the dark. It starts in the most brilliant light imaginable. These surface rivers are beautiful. They carve serpentine canyons into the ice, winding for miles, displaying a shade of blue so deep, so electric, it looks artificial. It looks like antifreeze. But this water is hunting. It is looking for a way down. It is looking for a weakness. Gravity is the engine. The water wants to reach the ocean, but the ocean is 30 miles away and 3,000 feet down. So, the water cheats. It finds a crack, a hairline fracture in the ice caused by the slow, grinding movement of the glacier over the bedrock below. The water enters the crack. Here, the physics of the ice sheet turn violent. Water is denser than ice. It is heavier. When it fills a crack, it acts like a wedge. It exerts pressure outward, pushing the walls of the ice apart. The deeper the water goes, the higher the pressure rises. It is a hydraulic lever, a crowbar made of liquid. The crack deepens. It widens. The water chases the tip of the fracture down, driving it deeper into the heart of the glacier. This is hydrofracturing. It is not a slow process. It is catastrophic. Suddenly, the river on the surface finds the opening. The water vanishes. A river, 30 feet wide, flowing at high speed, simply drops off the face of the earth. It plunges into a moulin, a vertical shaft, a throat of ice, leading straight down into the abyss. Stand near the edge of a moulin. You can feel the vibration in your boots. The sound is deafening. A jet engine roaring in a cathedral. The air rushing out of the hole smells ancient, stale and metallic, pushed aside by the torrent of incoming water. The water falls. It free falls for hundreds of feet, smashing against the walls of the shaft, eroding the ice, widening the throat. It is traveling from the world of light to a world of absolute, crushing darkness. It passes through history. In the first 100 feet, the water rushes past ice formed during the Industrial Revolution. It washes over soot, trapped in the layers from 19th century coal factories. Down further, 500 feet, it passes ice that fell as snow during the time of the Vikings. 1,000 feet, the Roman Empire rises and falls in the blink of an eye as the water plummets past. 2,000 feet, the pyramids are built. The woolly mammoth goes extinct. The water ignores it all. It has one destination, the bed, the floor of the valley. This is where the mystery deepens. This is where our exploration hits a hard physical limit. We know the surface. We can walk it. We can fly over it. But the subglacial valleys, the hidden canyons buried under 2 miles of ice, are as alien to us as the surface of Europa. We cannot send a diver. The pressure at the bottom of the Greenland ice sheet, under 3,000 meters of ice, is roughly 300 atmospheres. That is the equivalent of having 300 kilograms pressing on every square centimeter of your body. A diver would be crushed instantly. We cannot send a submarine. There is no open ocean here. There is only a complex, shifting network of veins and arteries, squeezed between the rock and the ice. We cannot send a camera. Or rather, we try. Scientists drill boreholes. They use hot water drills, melting a narrow passage down through the layers. It takes days. They lower sensors, cameras, turbidity meters. They lower them on long, Kevlar-reinforced cables. They watch the monitors in their tents on the surface, huddled against the wind, waiting for a glimpse of the floor. Usually, the screen shows nothing but blurry white, then blurry grey, then black, and then the signal cuts. The ice is not a solid block. It is a fluid. It flows. It deforms. As soon as you drill a hole, the ice tries to close it. It squeezes shut. The borehole deforms. The cable snaps. The equipment is lost. The ice takes it. We have lost countless sensors to the dark river. They lie there now, crushed against the bedrock. Expensive debris in a place no human hand will ever reach. But we know the water is there. We know because of what happens next. When that surface water, that sapphire blue melt hits the bottom, it changes the world. It doesn't just sit there. It pressurizes. Imagine a car on a hydraulic lift. You pump fluid into the cylinder, and the heavy steel car rises. The water falling down the moulins does the exact same thing to the ice sheet. It is called hydraulic jacking. The water forces its way between the bedrock and the ice. It pushes up. The entire ice sheet, trillions of tons of frozen water, lifts. It might only lift a few centimeters, maybe a few millimeters, but that is enough. The friction is broken. The connection between the ice and the rock is severed. The glacier is no longer dragging itself painfully over rough granite. It is floating. It is sliding on a greased rail. The glacier accelerates. On the surface, GPS stations register the jump. The ice lurches forward. It groans. The background hum of the glacier changes pitch, a deep, resonant thrumming that can be felt in the chest. This is the hidden engine of sea level rise. It's not just about ice melting at the edges. It's about the plumbing. It's about how efficiently the ice sheet can discard its own mass. And the dark river is the conveyor belt. But what does this river look like? If we could strip away the ice, if we could lift the white blanket and look at the naked bedrock of Greenland, what would we see? We would see a landscape of nightmares and wonders. We would see the Grand Canyon, but grander. There is a canyon running through the center of Greenland that rivals anything in Arizona. It is 500 miles long. It is half a mile deep, and it is completely invisible to the naked eye. Down there, in the eternal black, the water flows. It is not the clean, blue water of the surface. It is a slurry. It is thick. It is violent. As the glacier moves, it acts like sandpaper, coarse, diamond grit sandpaper. It grinds the bedrock. It shatters boulders. It pulverizes granite into a fine, silty powder called rock flour. The Sub-Glacial river picks up this flour. The water turns milky. It turns grey. It turns into a heavy, abrasive liquid that acts like a buzzsaw. It cuts channels into the solid rock. It carves potholes. It polishes the canyon walls until they are smooth as glass. We can't see it, but we can hear it. Seismic sensors placed on the surface pick up the noise. It is a chaotic din. The sound of boulders rolling along the riverbed. The sound of water cavitating under extreme pressure. The sound of the ice sheet cracking from below. Sometimes the water doesn't flow. Sometimes it pools. We have discovered lakes down there. Sub-glacial lakes. Pockets of liquid water trapped in the depressions of the bedrock, sealed in by the ice above. These are not stagnant ponds. They are active. They are pressurized chambers. In 2006, satellites noticed something strange on the surface. A circular depression appeared in the ice. It wasn't small. It was huge. Over the course of a few weeks, the ice slumped down. It sank. Why? Because beneath it, 2 miles down, a lake had drained. The seal had broken. The water, under immense pressure, had found an exit. It blasted out. It rushed down the subglacial valley. A flash flood in the dark, carrying millions of cubic meters of water toward the ocean. When the water left, the roof collapsed. The ice sheet slumped to fill the void. We watched it happen from space. We saw the aftermath. But we could not see the event. We could only infer the violence. We could only crunch the numbers and realize that the energy released in that drainage was equivalent to a small tactical nuclear weapon. Nature did this in silence, in the dark, without a single human witness. This is the frustration of the cryosphere scientist. You are a detective arriving at the scene of the crime, days after the culprit has fled. You see the slumped ice. You see the cracks. You measure the velocity of the glacier and realize it has sped up. You know the dark river is responsible, but you cannot map it. Not truly. Radar helps. Ice-penetrating radar is our eyes. We fly planes back and forth over the ice grid, blasting radio waves down into the glacier. The waves hit the layers of ice and bounce back. They hit the bedrock and bounce back. We build maps. We create digital elevation models of the valleys below. We can see the shape of the mountains buried in ice. We can see the deep troughs, but radar has a blind spot. Water. Water absorbs radar energy. It scatters it. When the radar hits a pocket of water, the reflection is bright, but flat. We can tell there is water there. We can tell where the bed is wet and where it is frozen. But we cannot see the depth. We cannot see the flow. We cannot see the turbulence. We see a mirror. We know something is behind the mirror, moving, churning, shaping the destiny of the coastline. But the radar only gives us the surface of the water. The floor remains unreachable. Think about the scale of this system. This isn't just one river. It is a vascular system. Capillaries of water feeding into veins, veins feeding into arteries. There is a theory, a terrifying one, called the runaway lubrication. As the climate warms, the melt zone on the surface expands. It moves inland. In the 1990s, the melt was confined to the edges. Today, in big melt years, we see surface rivers forming high on the plateau. Higher elevation means more potential energy. When water falls from a higher point, it hits the bottom with more force. It creates more heat. This is the feedback loop. The water is warm, relatively speaking. It is 0 degrees. The ice at the bottom might be -10, -20. The water brings heat, cryohydrologic warming. The water heats the ice from the inside out. It softens the shell. Soft ice flows faster than hard ice. The glacier speeds up. As it speeds up, it cracks more. More cracks mean more moulins. More moulins mean more water reaching the bed. It is a machine designed to destroy itself. And at the bottom of it all, the dark river swells. We try to model it. Supercomputers crunch the fluid dynamics. We input the variables: ice thickness, gravity, basal friction, water pressure. The computers spit out colorful simulations. They show us streamlines. They show us potential pathways. But a model is not a map. A map implies certainty. A map implies we have been there. We have not been there. There are places on the floor of Greenland's subglacial valleys that are more isolated than the surface of Mars. We have rovers on Mars. We have cameras sending back 4K video of the Martian horizon. We have drilled into Martian rock. We have never seen the bottom of the northeast Greenland ice stream. We don't know what lives there. Microbes? Almost certainly. In the few samples of subglacial water, we have managed to recover cloudy, silty fluid brought up in pressurized canisters. We find life. Extremophiles. Bacteria that have not seen the sun in 100,000 years. They eat rock. They eat hydrogen. They thrive in the crushing dark, in the cold, in the pressure. They live in the dark river. To them, the river is the entire universe. To us, it is a variable in an equation, a terrifying variable. Because the river connects to the ocean, stand at the terminus of a glacier. Stand where the ice meets the sea. This is the exit wound. The water that fell down the Moulin 30 miles inland. The water that navigated the dark canyons, that lubricated the bed, that lifted the ice sheet. It has to come out, and it comes out with violence. Subglacial discharge plumes. That is the scientific term. It looks like a boiling cauldron. In front of the glacier wall, the ocean surface erupts. Muddy, brown fresh water bursts up from the depths. It churns. It brings up nutrients from the bottom, attracting fish, attracting seals, attracting gulls. But it also brings up heat. The ocean water around Greenland is layered. Cold water on top, warm, salty water from the Atlantic below. The discharge plume acts like a mixer. It stirs the ocean. It draws that deep, warm Atlantic water up toward the face of the glacier. The dark river, in its final act, attacks the ice from the front. It brings the heat that melts the glacier's face, causing massive carving events. Icebergs the size of city blocks shear off and crash into the sea. Boom. Splash. Collapse. We film the icebergs. We count them. We name them. But we often ignore the invisible agent that caused the collapse. The fresh water. The dark water. It is a ghost. We trace its footprints. We measure its shadow. But we cannot catch it. Consider the complexity of the Moulin again. The gateway. Researchers have tried to send probes down these holes. Imagine a bowling ball-sized sensor. Rugged, packed with accelerometers, pressure gauges, sonar. They call it the drifter. They drop it into the rushing blue stream on the surface. They watch it disappear into the white throat of the Moulin. The data starts streaming back. Depth, 100 meters. Speed, 20 miles per hour. Pitch, roll, impact. The probe bounces off the walls. It spins. It records the terrified scream of the water falling. And then, silence. Usually, the probe gets stuck. The Moulin isn't a straight pipe. It twists. It turns. It has ledges. The probe gets wedged in a crevasse, buried under tons of rushing water, frozen in place as winter comes and the water stops flowing. Or, it makes it to the bottom. It enters the Sub-Glacial system, and then the rock flour destroys it. The sediment clogs the sensors. The grinding boulders crush the casing. The signal is attenuated by a mile of ice. We wait at the ocean outlet. We wait for the probe to wash out. We wait for weeks, months. Most never return. They are digested by the glacier. The ones that do return are battered, scratched, broken. They hold fragments of data, seconds of pressure readings that give us a fleeting glimpse of the hydraulic head, the pressure of the water driving the system. It tells us that the pressure fluctuates wildly. The subglacial system is not a steady river. It breathes. It pulses. During the day, when the sun hits the surface, the melt increases. The river swells. The pressure at the bottom spikes. The ice sheet lifts. At night, the sun dips. The melt slows. The pressure drops. The ice settles back down. Up. Down. Up. Down. The largest island on Earth is breathing. Inhale. Exhale. And the lungs are made of water. This dynamic nature is what makes it so dangerous to explore. If the environment were static, we could engineer a solution. We could build a drill that withstands constant pressure. We could build a robot that navigates a steady current. But how do you engineer for a chaotic system? How do you build a robot that can survive a flash flood of abrasive slurry 1 hour and the crushing weight of a settling ice sheet the next? We can't. Not yet. So we settle for the surface. We settle for the echo. We walk the white plains, listening to the crunch of snow under our crampons, knowing that beneath our feet a war is being waged, a war between water and rock, a war between friction and gravity. The evidence is all around us, if we know how to look. Look at the surface lakes again. The supraglacial lakes. Sometimes, in late summer, a lake doesn't drain. It freezes over. A lid of ice forms on top. Snow covers it. It becomes a buried blister of water. The next year, it melts again. But the structure of the ice has changed. The latent heat trapped in that water affects the ice around it. It weakens the integrity of the sheet. Fractures appear in patterns that mimic the spider webbing of broken glass. These fractures are the future. They are the premonitions of the dark river's expansion. They tell us where the next moulin will open, where the next injection point will be. We are seeing these fractures further north than ever before. We are seeing them at higher altitudes. The unreachable floor is becoming more active. There is a specific sound scientists talk about. You hear it when you are sleeping in a tent on the ice sheet. It's not the wind. It's not the shifting of your sleeping bag. It's a deep, resonant times thump asterisk, like a heavy book dropped on a floor in the room below you. That is a fracture opening. That is the ice sheet reacting to the stress from below. That is the dark river demanding more space. It is a reminder that we are guests here, unwanted guests, on a roof that is slowly collapsing. We map the valleys with gravity sensors. We fly planes that measure the tiny fluctuations in the Earth's gravitational field caused by the density of the rock below. Granite has a certain density. Sedimentary rock has another. Water has another. By measuring gravity, we can see the shape of the trench. We found a canyon that stretches from the center of the island all the way to the Petermann Glacier in the north. It is a mega canyon. If it were in the United States, it would be a national park. Tourists would flock to the rim to take photos. Here, it is a dark, frozen tomb. But it is the main artery. If the Greenland ice sheet is destined to collapse, if the melt accelerates to the point of no return, this canyon will be the highway. This will be the chute that funnels the ice into the ocean, and the lubricant is already there. The dark river is already flowing through it, greasing the skids, waiting for the tipping point. We study the unreachable floor, not because we want to conquer it, not because we want to plant a flag. We study it because it is the throttle. You cannot understand the car if you don't understand the brakes. And the subglacial valleys are the brakes. Rough bedrock slows the ice down, smooth bedrock speeds it up. Water turns rough bedrock into smooth bedrock. It is that simple and that terrifying. Every summer, the river works. Every summer, it sands down the braking mechanism of the Northern Hemisphere's largest ice reservoir. We stand on the surface, checking our watches, checking our GPS units. The sun circles overhead, mocking us with its perpetual light. We pack up our gear. We pull up the shallow sensors. We secure the camp. We look at the moulin one last time. The blue water rushes into the void. Endless, tireless, drop by drop, gallon by gallon. It is sending a message to the bottom. A message we cannot read, delivered to a place we cannot go. The river flows on, into the dark, into the future, and we are left on the surface, listening to the echo. The ice sheet is not merely a frozen blanket draped over the landscape. It is a lid, a heavy white lid screwed tight against the crushing pressure of the earth. Beneath it, in the deep scars of the subglacial valleys, lies something that challenges our understanding of life itself. We look at the surface and see a wasteland of white, sculpted by wind and indifference. We see beauty, we see emptiness. But if we look deeper, past the accumulated snow of 10,000 winters, past the compacted fern, and down into the basal ice that grinds against the bedrock, we find that the emptiness is a lie. The valleys are not empty. They are waiting. To understand why we dare not drill, why we hesitate to pierce that final veil between our world and the hidden one below, we must look at what happens when silence is broken. We must look at the nature of isolation. Isolation is a powerful evolutionary force. Leave a creature on an island for 1,000 years, and it changes. It shrinks. It grows. It adapts. Now, consider an ecosystem trapped not on an island, but in a pressurized, lightless dungeon for 1 million years, 2 million years, 5 million years. The biology down there does not play by our rules. It has been cut off from the sun, cut off from the atmosphere, cut off from the genetic interchange that drives the surface world. It has diverged. This is not science fiction. This is the biological reality of the cryosphere. In 2015, researchers examined ice cores taken from the Gulia ice cap in western Tibet. They drilled down, pulling up cylinders of frozen history. When they analyzed the ice, they found genetic signatures, bacteria, viruses. But these were not the flu strains drifting through our cities today. These were ancient. Of the 33 groups of viruses they identified, 28 were completely unknown to modern science. 28. They had been sleeping in the ice for 15,000 years. And they were not dead. They were dormant. This discovery sends a chill through the scientific community that has nothing to do with the temperature. It proves that ice is not a grave. It is a time capsule. It preserves genetic material with terrifying fidelity. In the permafrost of Siberia, scientists have revived a giant virus, pithovirus, Sibericum times, that had been frozen for 30,000 years. 30,000 years. It dates back to the time of the Neanderthals. When they thawed it in the lab, introduced it to an amoeba, the virus woke up. It invaded the host. It replicated. It killed. After 300 centuries of stasis, it went right back to work. Now, apply that logic to the sub-glacial valleys of Greenland. The Grand Canyon of Greenland is not just a geological curiosity. It is a biological vault. The water flowing there, the slush grinding in the deep pockets, contains the remnants of an ecosystem that existed before humanity walked the earth. If we drill into it, if we blindly punch a hole through the ice to satisfy our curiosity, we risk opening a Pandora's box that we cannot close. Imagine the scenario. The rig sits on the surface of the ice sheet. The wind howls, a constant physical weight against the metal siding of the research station. Inside, the team watches the monitors. The drill is a marvel of engineering, a heated, rotating probe designed to melt and cut its way down through 2 miles of ice. The drill descends. It passes through the modern snow, the fallout of the industrial age. It pushes past the ice of the Little Ice Age, past the medieval warm period. Down, deeper. It grinds through ice laid down when Rome fell. It pushes past the era when the pyramids rose. The drill is a time machine, moving backward, deeper into the dark. 2 miles down, the pressure is immense. The ice here is warm, relatively speaking, heated by the friction of the glacier moving over rock and the geothermal heat bleeding up from the planet's core. The sensors scream. The drill tip breaches the basal layer. It breaks through into the subglacial cavity. Success. The team cheers. They have touched the bottom. They activate the pump to bring up a sample of the liquid water, the slush that flows through the hidden canyon. They want to see what is in it. They are driven by the purest of human motivations, the need to know. But in that moment of contact, 2 catastrophes become possible. The first catastrophe is the one we fear for ourselves. The sample comes up. It is sealed, ostensibly, but seals fail. Containment breaches, or perhaps the very act of bringing the pressurized fluid to the surface causes it to atomize. We are introducing biological agents to our biosphere that have not interacted with surface life for millions of years. Our immune systems are libraries of past wars. We have antibodies for the flu, for the cold, for the measles. Our bodies remember the battles our ancestors fought, but our bodies have no memory of this. How could they? We have never met these organisms. We are biologically naive. If a pathogen exists in that deep water, a bacteria that thrives on sulfur and cold, a virus that lay dormant since the Remian interglacial period, we have no defense, no immunity, no cure, no vaccine. It creates a scenario of backward contamination. The introduction of a paleo-pathogen into a modern population. It sounds alarmist, perhaps, but biology is a numbers game, and the numbers are staggering. A single milliliter of that subglacial water could contain millions of viral copies. It only takes one to find a compatible host. It only takes one error, one dropped vial, one leaky seal. But there is a second catastrophe. A quiet catastrophe. One that keeps the ethicists awake at night, just as much as the epidemiologists. Forward contamination. We are dirty creatures. We are walking ecosystems. Our skin, our breath, our equipment, it is all teeming with life. Even the cleanest drill, sterilized with hot water and ultraviolet light and hydrogen peroxide, carries a load. It carries the signature of the surface. When that drill tip breaks into the subglacial lake, we are the invaders. We are the aliens. The ecosystem down there is starving. It is an environment of extreme limitation. The organisms that survive in the subglacial valleys of Greenland are likely oligotrophs, life forms, adapted to incredibly low nutrient levels. They grow slowly. They reproduce on timescales that would seem glacial to us. They hang on by a thread, metabolizing rock, metabolizing ancient carbon, surviving in the dark. Then we arrive. We punch a hole. We introduce oxygen. We introduce kerosene from the drilling fluid. We introduce a single, common surface bacterium, *E. coli, *, Staphylococcus, *. To us, these are mundane. To the subglacial ecosystem, they are super predators. Surface bacteria are fast. They are aggressive. They are evolved for a world of competition and abundance. If we drop them into that pristine, isolated valley, they could outcompete the native life in a matter of days. They could consume the limited resources, choke out the ancient lineages, and rewrite the biological history of the deep valley before we even have a chance to study it. We would destroy the very thing we came to find. We would look through our microscopes at the water sample and see only ourselves staring back. We would see the reflection of our own contamination, mistaking it for discovery. We would kill a world that has survived since the dawn of the ice, just by touching it. This is the dilemma of the unknown unknowns. We do not know what is down there, so we cannot design a perfect protocol to protect against it. And because we cannot protect against it, we cannot go down there to find out what it is. It is a scientific catch-22. The caution is not theoretical. We have seen what happens when we rush. In the 1990s, scientists drilled toward Lake Vostok in Antarctica, a massive subglacial body of water buried beneath nearly 4 kilometers of ice. It was the holy grail of extreme biology. They drilled and drilled, fueled by the excitement of the chase. But as they approached the waterline, the international community shouted, "Stop!" They realized they were not ready. The technology was too crude. The risk of contaminating the lake with drilling fluid kerosene and freon was too high. They stopped the drill a mere stone's throw from the liquid surface. They left a plug of ice between the drill and the lake, a safety barrier. They waited for years, developing new technologies, debating the ethics, terrifyingly aware that one mistake would ruin the lake forever. Greenland's subglacial network is even more complex. It is not just a lake, it is a flowing system, a canyon. If you contaminate one part, you contaminate the river. You send the pollution flowing downstream, deep under the ice, spreading the damage across hundreds of miles of unseen terrain. The biological time capsule must remain sealed. For now, we are forced to rely on indirect methods. We use radar. We use gravity sensors. We use seismic waves. We ghost hunt from the surface, trying to infer the biology from the physics. We look for plumes of methane that might indicate bacterial life breathing in the dark. We look for the color of the ice flowing out at the coast, searching for stains that might hint at what lies upstream. But we do not touch. We stand on the ice sheet, 2 miles above the valley floor, and we practice restraint. It is a rare thing for humanity. We are a species of explorers. We climbed Everest. We descended into the Mariana Trench. We walked on the moon. Our instinct is to go, to see, to take. But here, the ice demands humility. It demands that we acknowledge our own biological filth and our own biological fragility. The future of exploration in these valleys lies not in massive drills and brute force, but in microscopic robotics and sterile probes that we have not yet invented. We need melt probes that sterilize themselves as they descend, cauterizing the hole behind them, ensuring that not a single spore from the surface hitches a ride. We need artificial intelligence capable of analyzing the water in situ, down in the dark, sending back data instead of samples, so that we never have to bring the risk to the surface. Until we have that technology, the valleys remain forbidden ground. They are a planetary park, closed to visitors. There is a somber beauty in this restriction. It reminds us that we do not own every corner of this planet. Some places belong to the silence. Some places belong to the deep time of geology. Some places belong to the microbes that have been swimming in the dark for 1,000,000 years, unaware that we exist, unaware that we are walking on their ceiling, debating their fate. The ice holds its breath. The valley waits. Every winter, new snow falls on the surface of Greenland. It packs down. It becomes fern. It becomes ice. It adds another layer to the lock. It pushes the secrets deeper, burying them under the weight of time. We want to know. God. We want to know. We want to see the rivers that flow uphill. We want to see the bacteria that eat rock. We want to know if life down there resembles life on Europa or Enceladus. We want to answer the question, are we alone? But the price of the answer is too high. The risk of the question is too great. So we watch. We listen to the echoes in the radar data. We map the ghost canyons in our computers. We dream of what swims in the dark water. But we leave the drill rigs silent. We leave the ice intact. Because some doors, once opened, can never be closed again. Some nightmares, once woken, do not go back to sleep. And in the fragility of our own biology, and the fragility of theirs, the only safe move is to stand back, to let the ice keep its secrets, to let the biological time capsule drift on, through the dark, into the deep future. Preservation, protection, silence. These are the laws of the sub-glacial world. And for the sake of both the world above and the world below, we obey them. We stand at the threshold, and we turn back. We choose ignorance over destruction. We choose safety over discovery. The canyon sleeps. And for now, that is exactly how it must remain. We stand on the surface of the ice sheet, looking out at a horizon that seems to go on forever. To the naked eye, it is a blank canvas, a world of white, a silence so profound it feels heavy in the lungs. But we know now that this silence is a lie. We have peered through the veil. We have stripped away the layers of compacted time with radar, with gravity sensors, with the tireless grid patterns flown by aircraft for decades. And what we found beneath our feet is not a flat, dead basement of rock. It is a cathedral, a ghost landscape, a jagged, sprawling, majestic scar that rivals the Grand Canyon, yet remains completely invisible to the human eye. This is the great paradox of the Greenland mega canyon. We possess the map, but we cannot travel the territory. We have the coordinates, but we cannot reach the destination. It is a strange realization that in the 21st century, we know the surface of Mars better than we know the bedrock of our own planet. We have high-resolution photography of the Martian Olympus Mons. We have sent rovers to trundle across the red dust, to drill into the rocks, to send back selfies from a world 140 million miles away. We can bridge the vacuum of space. We can navigate the orbital mechanics of the solar system. We can land a robot on a moving asteroid, but we cannot go 2 miles down. The barrier here is not distance. The barrier is density. The barrier is pressure. The barrier is the sheer, unyielding physics of ice. To reach the floor of the mega canyon, to walk along the banks of that sub-glacial river, We would have to fight a weight that crushes steel. We would have to bore through layers of history that have remained undisturbed for millions of years. Space is a vacuum. It is the absence of resistance. The Greenland ice sheet is the opposite. It is the ultimate resistance. It is a wall that pushes back. And this brings us to the cruelest irony of this entire story. The tragedy of the subglacial world. We want to explore it. We want to sample that water. We want to find the extremophiles, the microscopic life forms that might have evolved in the dark, sealed away from the sun and the atmosphere since before the first humans walked out of Africa. We want to know what the Earth looked like before the Big Freeze. But the very thing that preserves this world is also the thing that prevents us from seeing it. The ice is the vault. The ice is the lock. As we watch the global temperatures rise, as we track the retreating margins of the glaciers, we are faced with a terrible trade-off. The ice is melting. Every year, billions of tons of water flush out into the Atlantic. The shield is thinning. Logic suggests that one day, perhaps centuries from now, the ice will be gone. The weight will lift. The canyon will be exposed to the sky for the first time in an age. The sun will hit the bedrock. The air will circulate through the valley. We will finally be able to walk there. We will be able to see it with our own eyes. But by then, it will be gone. The ecosystem we want to study depends entirely on the pressure. It depends on the darkness. It depends on the isolation. If the ice melts enough to let us in, the unique conditions that created this hidden world will evaporate. The subglacial river will just be a river. The pressure-sealed bacteria will die in the oxygen-rich air. The ancient chemical signatures will be washed away by the very meltwater that grants us access. It is a museum that destroys its exhibits the moment you open the door. So we remain stuck in this suspended state. We are voyagers who can look, but not touch. We are cartographers of a forbidden geography. We trace the path of the river using radio echoes, watching the data stream onto our monitors, painting a picture of a world that is right there, right beneath our boots, yet effectively exists in another dimension. A dimension of pressure, a dimension of darkness, a dimension of silence. We trace the lines. We name the valleys. We measure the depth. 750 kilometers long, 800 meters deep, 4 billion years of geology. We hold these numbers in our minds, trying to visualize the grandeur of a canyon that has never known the sound of wind. We imagine the water flowing in the pitch black, sliding over rocks that haven't seen the sun since the Pliocene. It is a humbling reminder that for all our technology, for all our satellites and drills and ambition, the Earth still keeps her deepest secrets. She holds them close. She buries them under a blanket of white, so heavy, so cold, and so permanent that we can only guess at what lies dreaming in the dark. We are left with the data. We are left with the radar ghosts. We are left with the knowledge that some places are not meant to be visited. They are only meant to be known. The Greenland mega canyon sits in the quiet dark, flowing endlessly toward the sea, safe from our curiosity, protected by the crushing weight of the ice. But the northern ice sheet is not the only place where the Earth hides its water. If the frozen rivers of Greenland feel inaccessible, the sealed reservoirs of the south offer an even stranger, darker promise. There is a place on the opposite side of the world where the water hasn't just been flowing, it has been sitting, still and liquid, for 15 million years. A time capsule trapped beneath the coldest temperatures on the planet, teeming with life we haven't met yet. Antarctica is hiding a network of subglacial lakes that makes the Greenland Canyon look like a mere scratch on the surface. If you want to understand what is waiting for us in the dark waters of Lake Vostok, watch this next.